All right. These are the last trig identities that I need to expose you to and show you how they work. Um, Honestly, for these particular ones, I just need to show you, like, I'm going to show you where they come from, but I'm also going to show you how to work with them. Um, it's important that you guys know how to work with these identities, and these are useful, but not the most useful. I would say everything else that we've done before this point applies, but just to wrap it up and kind of say we've done all of them. So here's what we're going to start with. Um, as the name states, it's product to sum. So I'm going to look at the sum and difference identities and figure out how I'm going to get a product out of that. So what I'm going to start with is I'm going to start with sine of x plus y plus sine x minus y. And so I'm going to go ahead and figure out what this equals using my sum and difference identities for sine. So I remember my story of Sinbad and Cosette. So I can rewrite this as, for this part, sine of x cosine y plus sine y cosine x plus, and this one I'll make it that, so sine x cosine y. You guys understand this cosine. Minus sine y cosine x. Okay? So if you notice, this is what I have. And if you look exactly at the terms I have, the four terms, two of them are going to cancel out. Specifically, sine y cosine x. Because they're both the same, except one's a positive version, one's a negative version. So really, I know that sine of an x plus y plus sine of an x minus y can be equal to 2 sine of x cosine y. And so this is where the product comes in. The product of a sine of an angle times cosine of a different angle, or of another angle, could be the same, could be different, is going to be twice what I would get from adding sine of x plus y and sine of x minus y. So I could say one of my identities is 1/2 sine of x plus y plus sine of x minus y. That is equal to the product of sine of x times the cosine of y. And that is a product to sum identity. Right? So I'm going to go ahead and pause, reset, and show you another one. All right. So that's what I got from having a sine of x plus y plus a sine of x minus y. So now let's talk about what if instead of adding two, like the sine versions, what if I did the cosine versions instead? So again, we're just going to go ahead and plug this into our sum and difference identities for cosine. So cosine was Cosette's way. Cosette sits with her friend at the booth, while Sinbad sits with his friend at on their side of the booth. Right? Plus Cosette and Cosette's friend plus Sinbad and Sinbad's friend. All right. And just like we did last time, notice there's still a cancellation that's going to occur. So from here, I can see that the signs cancel out. So this is equal to 2 cosine x cosine y. And so if my goal is to write this product in terms of a sum, then I could say this would equal 1/2 whatever the sum of cosine of x plus y plus the cosine of x minus y. Right? So that's what happens if I use sine of x plus y plus sine of x minus y, or cosine of x plus y plus cosine of x minus y. But consider what would happen if instead of doing the plus sign at this stage, if I would have subtracted. So go ahead and pause this video while I go ahead and reset and think about, well, what would have happened if we would have done a minus sign in this instance? All right. So if instead of a plus, I change that to a minus, then it's still the two quantities that I have, except now they're going to be subtracted. So that means that I'm subtracting this second quantity here. All right. And if I'm subtracting the second quantity, now this would be negative, and this would also be negative instead. That's what would happen. And as a result of those signs switching, because we're now subtracting, well, here's what would cancel out instead. The cosine xy cancel out with that cosine xy, and now I have a -2 version of sine of x sine y. And so that's a minus there. So I'm going to go ahead and divide by a -2 right here. So I have sine of x sine of y. And since I'm dividing by a negative number, if it was cosine of x plus y minus cosine of x minus y, dividing by a negative switches that order. So it's still going to be minus, but it's not x plus y first anymore. It would now be x minus y minus x plus y. That's what changes when you subtract now, because you're just flipping signs. So hopefully you guys follow through the sign flips, and if not, follow along with your own notes. See how that helps. So I'm going to go ahead, pause and reset, and then we'll talk about the last one where it's the last possible product. All right. So right now we have these four. Notice we have sine of x multiplying by cosine of y, cosine of x by cosine of y, sine of y times a sine of x times a sine of y. The one that we're missing that we haven't currently captured is what happens if we have a sine of y times a cosine of x, right? So in order to figure this out, we're going to go ahead and look back at the first problem that we did. Now, for the first problem, it was a very similar setup, except I changed the operation between the two sine functions right now. It used to be plus, now it's going to be minus. So as I'm setting this up, this should equal sine x sine y, sine x cosine y plus sine y cosine x minus sine of x cosine of y minus sine of y cosine of x. Okay, so using the difference identities, this is what, or the sum and difference identities, this is what I should get. So now if you notice, I'm subtracting. So that means that this is actually going to act as a plus, while this one over here is going to act as a minus. If I distribute that negative into that second set of parentheses, this is what I would get. I can see that the sine of x and the cosine of y cancel out. So you are left with sine of x plus y minus sine of x minus y should equal 2 sine of y cosine of x. And you can easily manipulate those to say that it is the product of 1/2 times sine of x plus y minus sine of y of x minus y should equal the product of sine of y cosine x. And those are these right here, the product to sum. So if I see a product of an like this, I could rewrite it in that form.